Hi everyone, so I'm going to talk today about the printer VZbot 330 and the printer I built myself, which is in certain ways similar to VZbot 330. So I'm going to explain what stuffs really need to be improved in the VZbot 330. I appreciate the amazing work is done by VZbot team, and I am not here to compete with anybody. I am not here to sell anything. I am not here to do. I'm just trying to help the community and the point they need to improve. And I can also upload all my designs, but I am leaving this VZbot so they can choose what they like to improve, or what they, if they even like any of my ideas, and what they can do to make things better. But just sharing my knowledge so people can know what's going on and how I think about changing stuffs to make it better. So let's start, for example, with this is the VZbot 330. That's what the files available online, the only one, because the CNC version is not available as a whole printer. So, and there's no issue with the 3D printed parts VZbot 330 or any printer I ever come across. I have printers last for many years and they're printing amazingly with printed parts, so that's not a big issue or major difference between a CNC or a printed part printer. But my recommendation 100% to use polycarbonate carbon fiber filament blend, because it's lightweight and it's stiff, so, and it's high temperature material, and also it's help dampening many vibrations rather than the aluminium, and also it's help also lock many screws, because the screws just get tight, you know, when they get in the plastic. It's not like aluminium to aluminium. That doesn't mean aluminium is bad, it's just I'm saying that's my experience. So if we hide some the cover panels so we can go to the structure more visible. So we start, for example, first with the cover. The printer to have this whole cover movable on top of the printer, that generates a lot of vibrations, and it's not fixed in any way. It's only fixed by hinges in the back. And just to let you know, I just hide the back electronic part of the printer because it's huge and just slow things down on my computer. So yeah, the cover, the top cover, the hat of the printer, it's very huge, and it's also movable, and it's also it's only holded by these two hinges in the back, which make things, you know, not a very good recipe for dampening vibration, or, you know, it's just, I feel the 235 version, it's more perfectionate version of the printer than the 330. So honestly, my recommendation, just keep the 235 design. Doesn't need to go with this top hat. So even if you choose this whole length of the printer, the same whole length as a one part, and then just put the gantry in anywhere you want in the top part, will be better than to make a top hat removable. So that's the first point. The second point, put here angles. So if it was one part, put here bigger angles. Even if it's 235, bigger angles with magnetic fixed top, so you can remove it and service the printer, will be a great idea. But bigger angles, so you don't let the printer twist on the top, but the bottom, its amazing job is done by putting this aluminum plate on the bottom. And but the top, the angles, I feel they are small and they're not very supporting for twisting. The other things, this bed assembly, it's outdated, honestly. These steels, you know, the steel, it's not solid like aluminum extension, and we will come to this point, the difference between fixing the bed to the aluminum extrusion of the frame, or rather than just have these 6 strings of vibrating guitar strings, which is the lead screws and these steel rods. Steels can vibrate and can generate a lot of movement. So imagine all this heavy bed with these 4 aluminum extrusions floating here with this vibrating bed assembly. Okay, I know it was meant to reduce the reduction of the selling cost and making cost, and also as a kit cost to be cheaper for the customer. But I feel the Trident, Voron, or any other Trident bed like Ratrig or any other printers they'd used was a more smart idea than to use just this outdated rod bed. And even if you still want to use this type of bed assembly, simply put just linear rails with more aluminum extrusion in this area. That will give support for this Y extrusions, and also will make it more precise, because I can see on Discord channel some people complaining about Z banding on the prints, which recommending you this is I don't know what they something name for this new version, just to stop backlash and these stuffs, and use a high quality lead screws or with the one they integrated in the steeper. Personally, I'm using the cheapest, the oldest style, and the lead screw, my lead screw, they all not straight. They all, when the beds come down and when the motor is rotating, these lead screws, they just go that right and left. So, and I'm not using the one with the integrated in the steeper motor, is just like the connectors. So doesn't affect the print quality. What really affect the print quality, the lead screw here on this design can move the bed, you know, if it have any misalignment. But if you use linear rails that's fixed to a aluminum extrusion, you never ever can, you know, the lead screw will follow the linear rails in the movement, so you get a perfect set even with the cheapest material. So that's another point. So also reduce vibrations in such a long printer, and also you know, you get a great Z quality without needing using these steel rods. The other points I want to point out, make this angle bigger. I made it bigger. So bring it here to the center of the printer. The printer is so tall, it can twist in any direction and can vibrate very easily. So just make these angles longer. Just make it longer and bring it to the center of the printer. And in my opinion, if you're not using a very like 4 or 5 mm panels, you need to put more angles on the side as where as possible, like anywhere is possible to use them, just use them, you know, because I feel this metal angle, even I use some of them, but they're not very useful to stop things from bending and twisting. Other points about the frame I want to point out. See, they was amazing idea to use 2040. Even I didn't use it in my printer, but was amazing idea to use because it's long design, and they use the width of the material on the Y direction, so that's why, just to reduce the vibrations or the movement of the frame or the twisting. Or but the problem they done here, you put the 2020 just reaching the half of this 2040. So what we got here, that's the side frame. Let's hide the rest. So that's the frame. My opinion, or my idea is just bring this 2020 to the end. I know the cut will be in the face of the printer, but that's fixed in 2 points. So the arm of the fourth, so that's the twisting point, the hinges point here. This all will be arm force fixed by 2 screws to the 2040. That will stop the twisting, you know, much better than this way. So you imagine when the Y is shaking, that's what's happening actually. So that's what's going on, you know. I know it's not visible, it's in micro or maybe even thousands of millim, but there is movement like this happening in the printer. That's another point. So if they bring this 2020 extrusion to the end, that will help a lot. Okay, let's go back without panels. Let's hide the panels again. I appreciate the innovation done by VZbot team, the amazing hot end design it's done, even the extruder, and the smart idea to bring the stepper motor close to the rail, which make less vibration, not floating, and make it vibrate with the Y movement. That also was amazing idea. Other thing I want to point out, which is the most important, the gantry. The gantry, I find the aluminium structure as a material, as an extrusion, when they start before CNC machining it, it doesn't have, you know, in the molecular level, doesn't have the alloy. It's not perfect. So the manufacturer process is not perfect. So if you scan this material by X-ray, you maybe find a weak spot. So when you CNC, and the weak spot is left, not the places that's going to be removed as removed material, that will make things worse. So you're not getting an even result, but keeping the whole tube as a closed tube. But just to reduce weight, use thinner material. Like the one I'm using, it's 1.4 millim. Maybe you can go thinner even if you can make a custom hollow square section tube. Let's isolate the tube. But the only thing can be improved to my tube is just make a V shape here to stiffen the threaded screw better than just to make it like a tube and then put nuts. Because if you want to put nuts, you need to make a bigger holes here so you can hold the nuts while you're screwing. So it's better just to make it a whole solid tube with threaded nuts, threaded screws, holes, but just make it thicker in this area specifically. Even if it's better engineered, just make it thicker in the area where the screws go. And definitely you need all the screws, because when you go with thinner material, the stiffness of the rail with the stiffness of the X-beam, it will make it a bigger stiffness in the material. That will help a lot with the stiffness. Because this, you combining two material, different material, the steel of the rail with the hollow tube of aluminium, which make it stiffer. I'm using 19 by 19, 1.4 millimeters actually. The rail I'm using, it's CPC, Taiwan made, very high quality rails. They also help, rather than using a cheap, brands, unknown brands rails. It's help because the weight, even the LDO, it's thicker and it's heavier than the CPC. The CPC rail, this lower section is thinner, so it's just lighter. I hold them both in my hand, the same length. There's a lot of difference. I don't have a scale, but there's a lot of difference in the weight. And let's come to the critical point, which I think need to be improved. The printer gantry support, or Y carriages they called it. It's very good in the printed version, but the CNC, I want to point up something about the CNC version. The CNC doesn't have this side support for the X-beam. What I want to explain exactly, let's go to shaded, or let's go keep it wire form, but just select this, isolate. Okay, so we get this side support. These side supports, they play a big role to increase the frequency of the gantry. You see, that's your force arm, and that's your hinge point when the Y gantry, the X-beam is vibrating. So that's your hinge point, and that's then the double span support point to stop it from vibration. So the distance between these, if it's double, you're getting more frequency, you're getting higher frequency. So imagine this is when you get these side supports, the hinge point is here on this edge, and the whole thing, this length, if the tube is extended to the whole length, is better, because this all is playing to support and stop the X-beam from vibrating. It's giving like a support. Let's explain it in some drawing. So if we got, for example, that's our beam, for example, and we go, this is the support point. So vibration is force also. So you're applying force, vertical to this beam. So what do you think will happen when you got support on these sides only like this. Okay, so the beam will come in curve like this curve. Oh no, that's circle. Come on, I am not perfect in CAD 2. Where's free curve? Ah, yes. So it will come like this, and then like this, and it doesn't want to go an angle. Yeah. So that's what will happen. But when you pushing that side also, that's the arm of the force, that's the hinge point. So if you put another support on the other side, how much is this support length? How much is the length of this? That's give a more support to stop the vibration of the aluminium CNC version of 330 doesn't have these side supports. It does have only the top screws, and the top screws, they're very close to each other. I mean the go through the screws from the top to the bottom, they're very close to each other, so they're not helping much in stopping the beam for vibrating. But my opinion, if we go back, yes, yeah, put support even on the CNC version. Make a model, something that can fit with the CNC carriages and just can support the beam from the side, which is fixed through the hole. That will play a big role. I know the CNC version, they have just aluminium hollow tube or just a U-shaped section, and they CNC it just to make it the gantry carriages. So it's hard to make you, because you have to start from a solid tube, and you don't need to go all the way from the bottom to top. I just make a big extension here on top and on the bottom, just to make things more solid, like just so, but don't do it all the way to reduce weight and material. And please use MGN9, MGN12. I know they release versions for MGN9. Why support? Because, and the short version of the block, it's about, I think, 70 gram between these two sides and between the long MGN12 block. So the MGN9 short version between it, and between the MGN12 long version, there is about 70 gram difference in the weight, 50 or 70, I don't remember exactly, but there is significant weight difference between them. And if you use a good quality MGN9, there is no issue with them, because I have mine I'm using now, they are running for many builds I done before, and for 5-6 years with no problem with them. So I feel MGN, and it's cheaper to use MGN9 of course than 12. The other point I want to point it in is come on my computer, yes. So you see the MGN12 or 9, this angle going this way straight, because there is a bolt passing here, but I started angle from this point and going straight to the pulleys, to the idlers, because I feel, where's your head's moving, your tool head is moving, where's in the movement, the rest just make it support for the X-beam. Not just to keep it gap is not necessary. Even if you bring this line more close to the center, and if it's not usable space, if your bed size, your design size is that's the limit, and your tool head is moving all over the bed, that's it. The anything left is just not used, but if you use it to support the X beam will improve things much better, because in this scenario you're shortening the X beam, and also you making this hinge and fixed point longer, which improve the vibration on the beam quite a lot. Let me think about the other points I want to point out. And try make the printer as heavy as possible, the motion part as light as possible. And to be honest, I'm using a smaller hot end, which is Rapido. So I modify the part to bring it up. I will show you my printer now, all the drawings, and this is, I don't know what they call this tube, I forget. Anyway, for cooling, I know it's necessary, but for my opinion, you don't need very strong cooling with the moving tool head. If you use a very strong fans of this accessory cooling, I feel will be much better than use a very strong fan on the tool head, moving with the tool head, which is also put on more weight than just using a small fan, which is useful in the high temperature material, even ABS, polycarbonate, nylon, anything. If you want to use a fan, you just use a small tiny fan, what I'm using, but make this very strong fan on the sides, which is will improve the layer cooling rather than just improve the cooling around the hot end. And I tested with these fans. I'm using a server fans, 70 mm server fans. It's doing well, no problem with it. And I use small fan, which is enough for high temperature material, but I don't need to put it on 30 or 20 speed. I just put it 100%. It's weak fan, so if you run it on 20, 30, it won't be enough even for some high temperature material, but so just make it full speed. So that's to improve more things. Other things I want to point out is this plate. This plate, make it a bit thicker, because the whole thing is supported on this plate, even the hot end. And this one thinner as possible, because more thin. I just using the small insert thread. This thread is not necessary, they're very long and they also heavier than the small thread, so I'm just using the small short version. Their height is 4 mm only, so I made this plate only 4 mm. But this need to be thicker, because that's what's holding everything on the rail. And I didn't use, let's hide some stuff, I didn't use these tubes. I don't know how to get them, where to get them from. It's carbon fiber, I'm not sure. No, I just print these tubes, modified to be in one piece with the upper and down parts, and I put a full screw all the way down. Well, that's will make it a stiff, so it's making everything stiff to the top plate, no twisting in the tool head. 4 full length screw on the back, on the front, and then just insert thread underneath here down, you see. So no short screws from the top and the bottom. I just go one long screw from the top. So I think this is all the points to improve the VZbot 330, the mechanical part of it. That's, I think, will be enough. Yeah, see, so that's just extend that to the front and make this shorter and just mount it by screw to these sides. And honestly, no top hat, just bring the mechanic down, make it full length as was you want, with magnetic support and big angle to support the top panel. That will make things better. And also I want to point this, you don't need this rail or this extrusion, you don't need it. Just keep the 235 mechanic, which was amazing, make it open, people can access their prints easier, nicer, and service the printer very easy from the front with no need for this one. Yeah, and keep the build tensioning on the front, and it's good, you know, because this size, I don't think even on this size of printer you need that extrusion on the front. If you put a bigger angle here, and also you can put a bigger angle on top, but not that big, even a bit smaller, that will make things work better, and the whole printer one piece. Every time you have to flip this gigantic thing, the top hat, to the back, then you have to find a space to flip it also, or you stand it on the wall or somewhere. I feel it's just unpractical, not much practicality on it. Okay, let's go back to my drawings. So this is my drawings. Let's hide this object. So you see my angles is bigger, the angle of the force. This is the support I done. The support I done for the rail, they have angle on the side, but they don't need to go all the way, so they can stop the X-beam from vibrating. And in reality my tube is a bit longer, so it's passing this support. And even I'm thinking to print the support go all the way close to the build, just leave a space for the build to pass, and that's it. Even I put angle here in this area to make things work better. And I made these parts up and down, both screw it to the blocks of the Y rail, because I feel it's better. I feel that's better. Because the whole thing's just mounted from the bottom, the whole Y, when it's vibrating, honestly it's a lot of force. Also, I know it's very tiny vibration, you just can feel it by hand, but try to stop this vibration. You can't. It's something crazy when you're doing the test, especially you can't stop these vibrations by hand and, you know, dampening them. So that's a lot of force applied on just support from the bottom. I know this is a pain to do the assembly, because every time you need to remove the X-beam, one side you screw it completely, and the other side I have to screw the block to the carriage with the rail, push it to the X-beam, and then screw the rail to the frame. So that's a bit downside of it, but it's also give you a better result because it's just two parts. And there was misalignment little bit I seen, and still, because I downloaded this VZbot 330 the other day, so the bolts where they are getting to the tool head, they not center perfectly when it's printed. So I have no idea about the CNC. And the other thing I want to point, also the CNC version tool head here, you got that aluminium part with a slotted head in it. That's also can vibrate. You know, imagine this is a plastic with screw running through, with a hardened steel screw running through. It's much stiffer than to be just a strip of aluminium with a hole in it. That can flex more, much more than, honestly, I feel it's just, that's also a difference. And you see my top bottom plate is shorter, and if I isolate, that's what I done. With insert thread down will sit and then screw to it. Okay, that's all. I just still using the default VZbot. I just done that for the ADXL support, and that's the fan. I'm using Delta. This fan Delta is very powerful. I know it's weak compared to the other fans, but I feel it's good enough. But then I also replace it. If I hide it, I replace it with Creality, very weak fan, but it's still doing well. It's 24 volt, but it's still doing well. And I modify that nozzle carriage from this side to fit. The fan duct I modify it to fit on this fan shroud and cooling. MGN9. And there was also a bit misalignment of the bolts with the idlers, so I feel, because you have to, let's go top view, you have to compensate for the thickness of the bolt. So this idler on this side, the smooth idler, they have to go a bit forward, like this direction, going forward and to the front and to the center, because the bolt is passing on their surface. But on the toothed idler, the bolt is inserting in the idler, so you have to keep that in your mind. So if you see the holes, they are not mirrored on both sides, so that's how things work. So they going more backward and toward the outside, to the side of the printer, and closer to the X-beam. Also here, you not worry about these bolts. These bolts, even if they misaligned, is if they are angles going cross, doesn't matter, because they're not playing any role in the printer movement. But if you have these bolts or these bolts misaligned, that's when the tool head is moving to the sides, is just shortening the build path, and when they're moving to the center, it's become longer because it's getting, the tension is changing between the sides and the center, even if it's 0.2 millim. You see the teeth, they going perfectly with the idler. I know they're not matching here, the teeth with the tooth of the idler, of the bolt, but just rotating it some degrees, it will match. But that's the center of the bolt to the center of the tooth. Also here and all the sides, so especially this idler have to be perfect, this and all aligned perfectly. And you see the bolts is going in the center of the support. Why? Because you're going to rotate it around the support and then tighten it, so it will just need to be in the center, exactly matching with the idler. And I think I moved this thing off. Yeah, it's just moved a little bit. Yeah, so that's how it should be. So that's the point I want to point out. Let's go to perspective and talk more about the hood end. So I ordered this inductive probe. I know everybody will complain about it because it's going to die soon. but I just don't want to spend money on beacon at the moment, so I just made this part, modify it. Now the other point I want to point out, the support for the hot end, you see, if I isolated, I made 4-point support on the top plate of the tool head instead of 2, because I feel 2 is not enough, especially with Goliath. It's just a long hot end and can vibrate a lot. Even it will give you better result with the input shaper testing, resonance testing, because it's dampening the vibration, but yeah, I feel it's just this is more accurate to do ways. I'm using Sherpa Mini, the extruder, and what's else to point here on the mount? Nothing. I use the same VZbot for Rapido fan mount. And you see the mechanic of 235, the parts I just fit it on Voron sized 350 printer, and I done some improvement on this idler. So what I done here, you see these holes is closed because just for printing, so they don't need support. So I done 3 holes so you can unmount the stepper motor easy when you want to replace your stepper motor. Also a big hole for idler, so I mean for the pulley of the motor, sorry, so you can take the pulley off and on easy and replace it if you feel something wrong or you want to clean it without accessing from the back. So also that point I want to point it out. Even for this Y, every time was turning when it's hit by the axis, so I just make it 2 screws instead 1 screw. The end stop 2 point more. And you see, even I'm putting 1 screw here. Don't worry about the drawing because they still have some stuff left from the old drawing. So if we go to hide this and hide objects, why is switching views? So I know these screws left from the old drawings, but I just have 1 hole drawing for 1 hole for the screw and 1 for the X and the stop, and only I put screws from the top. Even I made the hole from the bottom, but I didn't put any screws from the bottom. Yeah. So let's show some other layers. So layer 2, so that's the frame I am using. You see I am shorter because it's Voron 350, so I am not getting 400 height printing, but that's also maybe helping, yes, because, and my angle, the angle I made it bigger just to make things more stable. I brought the spool on this side, so you don't need to go on the back of the printer to change the spool, and just put it on the side and bring it on the side and on that rail. And what's else left? And just for the formation, I'm using the round shaft LDO motor, the super power motors on the front, and I'm using not round shaft on the back with the high temperature version, but the front one they're not high temperature version, but I feel they will be fine. We're not going printing thick all the time. So, and that's what I done just to make my own X-beam. So I made the holes very tiny just to mark the holes on the aluminium tube, and then just drill it by hand. Yeah, so the bait is removed here. So, but this is not my actual frame size. This is the VZbot 235. So I'm drawing everything there, but to make it work, you see, even this is a panel. So I just brought the trident bed assembly, put it on my frame size I'm using, and get the measurements so I can do these cuts, the back cuts. I think that layer is locked here, so the back cuts, and yeah, and that's my electronic assembly, how I done it. I just done it this way, and one power supply here, one power supply here, and there the raspberry and everything sitting here with the SSR and everything, and all the cables going this way. So it's just like one cross. I know it's a bit messy, but it's just for myself. And yeah, so I'm just using like these cheap lead screw nuts. Not these steeper down, they're just using normal connector, so that's how I done it. Let's see if there is any point more I wanted to point out. Yeah, that's even I make it thinner, so I took some mass from the bottom of this part. Even I make the section of these round cylindrical stuffs, I make it smaller, and everything on the motion gantry part is all polycarbonate carbon fiber, no ABS. Even if your motor is going 110 degrees hot, they never get deformed or get soft or anything. And they're lightweight for the moving part, especially if you just the tool head and the gantry carriages, just make it PCCF and you will be fine. Yeah, so I just encourage people, just print like these parts. If you can do CAD, and just print these parts and just try to test your aluminium X-beam and see what you get. Maybe get a lot of improvement rather than the aluminium support, which is the easiest things to do before you go and change your beam or you go do something else. And I don't have VZbot X-beam yet. I ordered and it's coming from Milo because I want to test it myself and see how it will do. And I think that's for today, and thank you for watching, and hope you learn something new. And please correct me if I am wrong. I know I'm not, I'm just my knowledge, my physical brain, that's what telling me to talk about it, and just trying to help other people. And I will leave any official modification to VZbot team, and because they're amazing team and they done huge improvement in the 3D printing and helping the community in the 3D printing, because I feel it's, yeah, the VZbot is one side and most of the other printers on the other side, because it's in two cases cost effective, also it's high speed, which don't see. I know there is the Annex engineering printers, but they're not cheap to build, so yeah. Okay, and take care everybody.